This one is the first problem. In this problem, we have to find the kinetic energy of two colliding trains. This demonstration was performed in 1896 in front of 40,000 spectators. In this problem, the two trains are approaching on 6.4 kilometer railway track starting from rest, and they have the acceleration of 0.25 meter per second square. Just before the moment of collision, we have to find the total kinetic energy of these two trains. The two trains are approaching towards each other on a track of length 6.4 km starting from rest. Now we have to find the total kinetic energy of these two colliding trains just before the collision. Now consider that these are the two trains and the speed is v. Each has the same speed v just before the collision. Why both trains will have the same speed? Because both are the identical trains and they have started from rest. They have the acceleration of 0.25 meter per second square. Before they collide, both will travel 3.2 kilometer. That means they will collide at the midpoint of the track. Now we have to find the total kinetic energy of these two colliding trains just before the collision. Let us consider that each train has the mass m, this train has the mass m, and this train is also has the mass m. Hence, total kinetic energy will be equal to half mv square plus half mv square. The total kinetic energy will be simply added because the kinetic energy is a scalar quantity. That's why this kinetic energy is half mv square. This one is also half mv square. This kinetic energy for one train, this one is for another train, and the kinetic energy is scalar quantity. You do not confuse with the direction. Simply the kinetic energy will be algebraically added because the kinetic energy is a scalar quantity. Hence, the total kinetic energy will be equal to mv square, where m is the mass of each train and v is the speed of each train just before the collision. The value of m equals to 10 raised to the power 5 kg. Now we have to calculate the speed of the train just before the collision. The train starts from rest. That means the initial speed of the train is 0 and the train travels 3.2 kilometer before the collision. Let us the speed is v after traveling a distance of 3.2 kilometer, and we have to find this speed v. As the train has the constant acceleration, hence we can apply v square equal to u square plus 2ax. As we know that the speed u is 0, acceleration in the problem is 0.25 meter per second square, and the value of x is 3.2 kilometer, which will be converted into meter, and it will be write down 3.2 into 10 to the 3 meter. Now the value of a equals to 0.25 meter per second square, which is given in the problem, and the x will be equal to 3.2 into 10 raised to the power 3 meter. Put all these values in this equation, then you will get v square equal to 0 plus 2 and 0.25 meter per second square. This one is the acceleration and this one is the 3.2 into 10 raised to the power 3 meter, and after some calculation you can get the value of v, and the value of v will come out 40 meter. This one is the value of the speed of each train just before the collision. Now we have to calculate the kinetic energy. The value of kinetic energy will be equal to mv square. Hence, put the value of mass m and the speed v that we have calculated. Hence, the kinetic energy is given by mass of the train is 10 to the 5 kg and the speed will be 40 meter per second. That means 40 whole square. After simple calculation, you can calculate the value of, the value will come out 1600 into 10 raised to the power 5 joule. This one is the total kinetic energy of the two colliding trains just before the collision. This energy is equivalent to detonation of approx 45 kg of TNT.
Collision buckling train cars, sending them falling off the tracks like dominoes. Two freight trains, locomotives somehow ending up on the same track this morning near Panhandle, Texas, crashing head-on. A mountain of twisted metal explodes in flame. Thick black smoke drifting toward homes forces mandatory evacuations for half the town.
Now we are going to discuss about the next problem. In this problem, a particle of mass m is projected with a speed u. This one is the speed u, and the angle is theta with the horizontal. Then it will follow a parabolic path in the vertical plane. We have to find the kinetic energy of this particle at this point. This one is the highest point. At this point, the speed of the particle is u cos theta. Now we have to find the kinetic energy of this particle at this point. As we know that the kinetic energy is given by half mv square. Kinetic energy equal to half m into v square, and it will be equal to half mass of the particle is m, and the speed at this point is u cos theta. Hence it will be u cos theta whole square. That's why the kinetic energy of the particle is given by half m u square cos square theta. In this problem, in general, students are thinking that the kinetic energy at the highest point will be 0. They are generally thinking that the speed of the particle at the highest point will be 0. If the particle projected vertical upward, then at the highest point the particle will have the 0 speed. You should not confuse with this case. Here the particle is projected with a speed u at an angle of theta with the horizontal. That's why the speed of the particle at the highest point is u cos theta, and hence the kinetic energy will be half m u square cos square theta. But if the particle is projected vertical upward with a speed u, then at the highest point the kinetic energy will be 0.